Going to look at some mass spectra now. We've come across this before, but now we're using it to try and identify and analyse organic compounds. The one that they've given us to look at here is pentanthreone, which I've drawn out below. And then at the left hand side I've just given us its molecular formula. So C5H10O. The first thing that I would look at on a mass spectrum of an organic compound is just matching up the peak furthest to the right with the MR of the compound, which in this case is 86. So I'm fairly happy that there we go, we've got a peak at 86, so this is matching the MR. This is known as the molecular ion peak, which we'd abbreviate as M+. So this is the whole of the molecule which has gone through as an ion being detected. Remember, when you're showing the fragments, make sure that they always have a positive charge, so the species all need to be cations. Okay, what else can we get from this? Not really asking us for it, but standing out there we've got two other pretty significant peaks, one at 29, one at 57. So these are fragments of the molecule. What I've done at the bottom there is chop my molecule up into bite-sized chunks, and now I'm just writing down the mass of each of those chunks, and I'm going to try and work out where my 29 and 57 have come from. Let's start with the 29. So I think we can see it's fairly easy that the 15 and the 14, so that end of the molecule, the ethyl group, gives rise to a peak at 29. So that's going to be a CH3, CH2, not forgetting we need a positive charge on that fragment. What about the 57? Once they get a little bit bigger, sometimes it's easier moving back from the molecular ion and working out what might have dropped off. In this case, so if we move back from 86 to 57, then that's a loss of 29. So we can think of it that we're losing a CH3, CH2, or if we build up from the start, how do we get to 57? Well, a 15 and a 14 and a 28 will also give us 57. Whichever method you use, we can see that the part of the ketone that's giving rise to 57, just highlight it now, is that section. So CH3, CH2, CO, and again it's got a positive charge on it.